Hey everybody, we're back. That was super quick. And you morphed. You changed.
Look at that.
So we did the presto changer. You might have heard a lot of little whispering behind the scenes here as we were secretly swapping you out for swapping somebody else out for you. Excuse me, we didn't swap you out. I think that's you over there. Yes. Okay. Good. So welcome back after that couple seconds. I really hope that you enjoyed the previous sessions on 3D printing as well as the Lego stuff that we're doing. We're going to talk about some other types of communication here. Oh, by the way, I'm Pete, and this is Jeff. Jeff is HTML guy. I am the XAML guy, but we basically just spend all this time picking on each other up here on screen. So what we're going to talk about for this session is Bluetooth, right? Is this the Bluetooth one? Yes, this is the Bluetooth one. Yeah. Okay, good. So I have to make sure. We've been doing enough sessions today. It's starting to get kind of punchy in the afternoon. I want to make sure that we are, yes, we're on Bluetooth. Good. Otherwise, okay, yes, great. So we're going to, I was just told we're live. Thank you very much. Hopefully you guys caught some of that stuff. It's not so smooth on that transition. I think we need to work on that on the next one. So we're going to talk about Bluetooth here in this particular unit. You actually have a Bluetooth robot next to you. We're not going to be showing that particular robot here, but it is Bluetooth controlled. It's very similar to the robotic arm we showed in the previous session that was controlled via USB, except we controlled that over Bluetooth. I do have some other cool toys here. So this is a Sphero. Anybody wants to? Whoop, there we go. Sort of opposite there. So this is a Sphero that we'll be demonstrating here. This is the small Sphero. This is not the the Peacekeeper, or there's a Sphero that's 3 feet by 3 feet. We did not bring that in here. I'm not interested in causing destruction and all sorts of stuff like that. So we are going to be talking about Sphero there, and we're also going to be talking about how to control this stuff too. Okay. So everybody see this? Here, here we go. Sorry, one more thing here. It looks like a shoe on wheels. But this is a very inexpensive, remote-controlled, I'm all backwards. Here we go. Remote-controlled robot almost that you can control via Bluetooth. And it's funny because I had both the Sphero and I had that particular device sitting out there, and there are lots of people actually trying to work outside in that office. And they're all working on like really intense projects and stuff. And I dropped the Sphero on the floor and I started controlling it around, and everybody stopped. Like nobody was interested in working at that point anymore. And I'm sure if the PM came in, they would have been like a little annoyed that I was distracting everybody with this. It's kind of like, people talk about this as a cat toy. I found it works equally well on geeks. If you put it in a room, everybody's like just sort of swarming all over it, right? So cool. So we're going to talk about how to control this stuff from Bluetooth today. So let's talk a little bit about Bluetooth in Windows 8.1. There are a couple of different types of Bluetooth APIs that you can work with in Windows. The first is RFCOM, and RFCOM is the general device control stuff. You're going to be using this for robots and things like Sphero and everything else. If you think about controlling something over Bluetooth using a serial type communication, which is the most common implementation here, that is going to be RFCOM. The second one is GATT, which is for low power devices. So, for example, I was talking to Chris Walker from Netwino before. He also had created the Agent Watch, and the Agent Watch is something that has sensors and things on it. If I remember correctly, the Agent Watch is an example of something that you would connect to via GATT. I could be wrong, but I do believe that was the case there. Also, low power sensors and things that you're not actively controlling, but you want information from. That's all stuff that you can use GATT for. So we've enabled app developers to create apps using both of these types of APIs in Windows 8.1. All right. If you want to create a connection in Bluetooth over RFCOM, we'll go over some of this code here in a second. You're going to use the device enumeration API. We talked about that earlier, where I mentioned this is an API that you're going to want to get familiar with. We used it in, was it a printing example or something else? Actually, no, it was in the camera and microphone example, where we were able to control or list all of the devices that matched the camera device profile on the machine. This is another one where you can check all the types of Bluetooth devices that meet a certain type of profile on the machine. Once you get those back, you then find the device, you get the selected device, and then you call connect async. Now, what's really interesting here is the Bluetooth communication that we do over RF-COM uses sockets, right? So if you know how to program for sockets using TCP/IP or UDP or any of that stuff on Windows, you'll know how to program across Bluetooth, because all that changes is the connection itself.
One thing to add there too is when we talk about devices, it can also be from device to device that connect via Bluetooth and pass information back and forth to one another. It's a way to transfer files or to connect two devices that want to play a game together. When you make that connection, whatever type of data you pass back and forth is up to you.
Yep. And we also have the ability to find the peers. So there's like peer finder type stuff, and you can find like what's available.
Yeah, the interface for programming in Windows is very simple. It doesn't take a lot of time to get caught up on and understand what's happening, and makes it real easy to do that programming.
Right. Now, if you want to program for a GAT, you're typically getting some event-driven data back that a value had changed. Again, you're not controlling, you're getting information back. And so you'll get that back as a buffer, and then you're going to read that and then do some processing on it. Again, very simple once you've done the initial connection. So what I wanted to do here is show a quick demo using Sphero. So let me go over to, if we can go to the camera here, I'm going to lift this up in a second. I guess probably the center camera. You don't need to necessarily see everything that's on the screen here. But I have regular Surface here, Surface 2, and I also have the Sphero. Now, the Sphero will communicate with the Surface here, or they'll communicate with each other over Bluetooth. Now, there is actually a Sphero API that wraps all this, so I'm not going to go into details on how to use that. We'll see the Bluetooth code itself here in a second. But if I wake this up, so I've tapped it, so sort of like cracking an egg. And if I go over here, I've got, oh, here it is. Let's move that over so you guys can see my notes. See, does it say it's connected? Let's see. Can you hold that for me for a second? Is it still blinking? All right. Let's see. Oh, yes, there we go. All right, it was just suspended, and my code, or that code didn't handle suspension. So let's try this again. There we go. So now we're connected. See if we're still there. So is it moving in your hand?
Yes, it is.
Is it moving? It's like the shiatsu massage thing, right?
Something like that.
I can change the color. Can you, here, why don't I, here, put it in the middle? There we go. We'll make this easier for the camera, guys, because I see you sort of like trying to juggle over there. So that if I take this, I can change, I don't know how well the color changes will come through, but if I make it really red, and then if I make it really, let's say purple. We're testing your camera calibration, by the way. We're just trying to see here how you handle saturated colors. All right, the other thing we can do, let's clear just a tiny bit of space here. Are you going to catch if it falls off? All right, so let's see. Let me move this guy over here. This is live, folks. All right, so I can take this. You're going to see it move, and I always forget which way is forward. Oh, that way is, there we go. So we do that. See if I can send it your way. There we go. Is that coming through at all? All right, we're doing our best to capture this on camera. I think for the most part, you're going to have to trust us that is in fact moving.
Yeah.
There we go. All right, enough of that. I'm going to hurt somebody.
I think the idea is made.
I think everybody knows. We're just going to play here with the cat toy all afternoon. But so this is the sample app that came, that is available on, I think it was on GitHub for that's as part of the Sphero API.
And it's running on an RT device, so ARM-based device.
Works perfectly well on ARM-based devices like this. It would work on this if I had Bluetooth on this, but unfortunately I don't have Bluetooth here, which is why I needed to use the remote thing. And true to the PCs that we're dealing with here, they also didn't want to use Bluetooth even when I connected a dongle in. So again, I'm going to blame the camera people for these crazy PC configurations. It's right, we're going to blame you guys for everything. I know that, and then you're going to start getting like unflattering shots of us on stuff. So the Bluetooth API that is wrapped by the Sphero API on GitHub is the same across Windows 8.1, Windows, any of the 8.1 flavors from ARM all the way to x86 and also 64-bit as well. So it'll work equally well across all of those. And it's something that I think is more tablet-oriented, but at the same time, certainly there are laptops that have Bluetooth and everything else. So I think there are no issues there. The Sphero API is available for free And again, the source code and stuff is available for you to see on GitHub. These, the robots themselves weren't that expensive. You can get these on Amazon. I don't recall the exact price, but they were not expensive at all. And I saw, in fact, that they have a new one coming out this fall that they advertise. And it's funny because they still call it Sphero, but it's more cylinder shape with two like big knobby tires and stuff. So it could be a lot of fun with that. And also, in the theme of the previous session, fun for kids as well if you want to teach them how to do stuff, but also fun for adults, as you saw over here. We can see that. Now, that is not as fast as that goes. It has some acceleration. Like, you can get these things going fast enough to jump. The kit itself comes with a little set of jumps that you can just send this thing flying over. I thought that might not be appropriate for demoing on the table. I was already going faster than I thought it would be. So that's kind of a really cool thing. And again, we'll have links to all the APIs and stuff, so if you want to play with those. The Sphero stuff just works right out of the box. Nothing to think about there. Now, I have a different robot here. And this is, again, this is from a company called Dagu, something like that, DAGU. Let me see if I do this in the front. You might be able to see that it's got some intelligence on board, right? It's got a couple of motors, so it can do some, good, it can do steering. It doesn't have to use tank-like steering. It can use actual car-like steering. It also has the onboard Bluetooth, right? And so the interesting thing with this is it's $29, right? So for $29, I get this whole thing. Now, the funny part is it's called an iRacer. Only works with Android. So I don't know how they got the branding done there for iRacer. It only has an Android app, but okay, whatever. I won't question them that. But it was very simple to build an app that works on Windows for this. I mean, once you understand they've published their control set, and it's a bunch of 1-byte commands where the first nibble is a direction and the second nibble is a speed. So all you need to do is write some code that can communicate over Bluetooth serial with that. So let's take a quick look at that. Let me see if I have this up here. Have you done anything interesting with Bluetooth yourself?
So last year I built an app basically for kids to play together, where you could each draw pictures and transfer them from one device to another, and we use Bluetooth for the communication there to pass the data, the image data, back and forth.
Cool.
So it was an easy way if you wanted to make a low entry scenario where it wasn't difficult to get data from one to another. You didn't require an internet connection, just two devices. We actually used NFC to make the connection,
yep,
and find the other peer, and then a Bluetooth socket that connected the two.
Okay. So what I've got here, I'm going to show source code first, and then we're going to have another task for the camera people to follow something moving around here. But this is a Windows Store app using Bluetooth, and I'm using the commands that they have to be able to go right and forward, left and forward, straight, turn either side. It's not the most robust stuff. There is no error handling or anything in here, but as an example of how to connect and how to work, I think it's pretty good. So let's just take, excuse me, sorry for everybody at home who had to hear that. So let me just take a quick look at the code. So the first thing that we're going to do is populate a list of devices, and that list of devices is going to be all of the Bluetooth RF comm devices on this machine. I could have been more specific and done stuff with profiles, but I didn't want to do that. So when I run this app, you'll see it lists the Sphero, and it also lists this iRacer. All of the pairing for these devices is done for you in Windows, by Windows. You don't have to go through and deal with pairing or any of that stuff in your own code. It's just done under PC settings. As a matter of fact, I think I'll show this here very quickly. If I go under, settings, and if I go under change PC settings, this way, here we go. Change PC settings, then if I go under PC and devices, Bluetooth, this is where you can automatically just pair with all the devices, right? So taken care of for you. You don't have to really think about it in your code, which is a huge help because one of the things when I was looking at these APIs, I said, how do we pair with this? Like, how does it know what device to pick? Because that is non-trivial code to have to write. That's not stuff that you want to put together. So what I've done, if we go back to the code here, I populate this device list. It again, using that device information, find all async, and it's calling this get device selector so that you don't have to know the hard-coded selection information to be able to pick the right kind of devices. Notice that I'm using RF comm serial port. So that's the RF comm, the SPP, serial port profile. There are other ones in here, like file transfer and other stuff. Excuse me, sorry. There's also phone book and a bunch of other things like that. But for the most part, we're going to be doing this just with these types of devices. If I get more than one device, I populate those in a list box. My throat's starting to go now. I populate those in a list box, and then if we don't get any devices back, I say no compatible devices found, which during debugging I saw quite a bit. And then if you select the device and want to connect to it, that's when I go and I get the available devices selected item. So I get whichever one it is that we're going to use, and then I call the from ID async, which will get me the actual device based upon the ID that I had stored, the descriptor information. And then if that comes back and it's valid, you'll find there's a lot of code when you're working with Bluetooth where you'll say if what comes back is not null, then go ahead and do this. That's sort of standard across even all the device APIs. If I get back a valid object, I create a new stream socket, and then I connect to it. And this is standard sockets programming. And then I create a data writer. And then all the stuff that I do from the rest of this is I just send bytes out to the data writer. So if I want to send a control message, I have it send a direction, and then I read the speed directly from a slider on the UI, which we'll see. I format the code here, and honestly, the most complex code I wrote in this whole thing is just to shift the couple of things over. I write the byte, and then I call the store function. So then you look at each one of these calls. It just calls that function, send control message, and it passes in this racer direction, and that direction here is just this enum that I set up. So if you look at this code here, I've got a lot of event handlers. You could certainly do this in less code. But if you look, the actual code here to connect to Bluetooth and send messages out to do something meaningful is really, there's not much to it. So what I'm going to do now is I'm going to turn on this device. There we go. He had just given up on me, and now I made him run back. So let me turn on this device. Hello. Turn on this device. There we go. Okay. It's that moment where you're like, oh crap, battery, don't be dead. So you see right here, it's blinking. You probably see some blinking stuff, depends on your frame rate. You'll probably see some blinking stuff there that shows that it's not yet paired, or it's not yet having any communication. It is already paired. And I'm going to go over to the app that's on my machine. You'll see this in a second, because I unfortunately only have two hands. I'm going to list the available devices. Here, can you play Vanna White? So I've listed the available devices, and then this Linvor or whatever, that's what it shows up as. So I'm going to select that, and then can you tap that button over there on the side? Let's see. All right, so now the light is now solid, right? So I'm going to put this back on the table here. So the light is solid. That means I am connected. Oh, that's just the power. All right. You can only say that with laptops and tablets. It's just the power. Okay. So I'm going to kick the speed up. And because for some reason it only wants to work on max speed here, so I'm going to make sure that you have something useful to catch. Let me see if I send it forward. Hit stop. Sweet. All right, let me get this forward again. And hit stop. All right, can you hold this just sort of like that? And let me see if I can turn the wheels. Yep. Stop. And turn the wheel the other way. Stop. Turn without moving. Stop. Turn without moving. These are all the different commands that it has available to it. Again, I go forward or backwards. And actually, this is the first time every command I've done worked, so that's really exciting. All right, cool. So let's set that down. And talk just a little bit more about the code here. Let me turn this off. By the way, one of the things with this particular little robot, if you let the battery go dead on it, you're sort of hosed, right? Because when the battery goes dead, it's a $29 robot, right? When the battery goes dead in here, it won't charge. And the instructions said, well, all you need is a 5-volt source, and if you jump these two traces on the board temporarily with the 5-volt source, you can, kickstart the battery again. So it's funny. It's like with this robot, you need a tiny little set of jumper cables that you can use just to make sure it can get going, right? So I mean, I've got a lot of that stuff in my travel bag that always gets me the special search at the airport. But I just was hoping not to have to deal with that today. So very cool. You can get that. So let me, in just a second here, let me pull that up and let you see. Let me see if I search Racer so you can see where to get it. All right, let's go ahead and show this. So that's the iRacer device itself. Very easy to build your own app to be able to use that. Okay, and you get them. You see, I wasn't lying. It's only $29.95. Okay, good. So really, this was a fairly short session. But what I wanted to show folks here is that you're able to access Bluetooth through a couple of different ways. One is that there are existing SDKs that have been built. One example of that is the SDK for Lego, which we showed some of that in the previous session. That also works over Bluetooth. Another example of that is the SDK for Sphero. Again, people are just wrapping our APIs, making some really good SDKs to do that. And then finally, if the protocol is simple enough, a 1-byte command, it does. Anybody watching this can certainly handle sending 1 byte over serial. It's not really hard. There's no computer science needed for that. Even the bit shifting, you could have gotten around that by using a different enumerator, just adding the two numbers and sending it over, right? So I think that's something that is really easy to do, even also for your kids, not just for you. Again, a great father-daughter, mother-son type activity where you're able to, involve your kids in learning how to program something. Because if you think here, this is not going to be as accurate in movement as something like the Lego device, but you can create apps that not just are remote control by, sending these commands one at a time by pressing buttons, but you could have it, say, program a set of commands. So again, like the logo thing, where forward 1, turn right, go another 1, for a couple of seconds or whatever. You could set up, have your kids write a program like that to learn how to control things and see stuff that happens in the real world. So cool. So Bluetooth, again, lots of fun. And there's also a lot you can do with Bluetooth on Windows Phone. We're not doing anything with Windows Phone here, but definitely I want folks to know that Windows 8.1 with the new Bluetooth APIs can control just about everything. If you see something out there that's sort of old, like the iRacer's been out for several years, and it says it only supports, it doesn't support Windows because we don't have the APIs. We do have the APIs now, and if you want to work, write your own code or ask them about, what their standards are, like what the message is, you can hack together pretty much everything. So cool. So thank you very much. And join us again here in another, I think it's 10, 15 minutes or so, where we're going to talk about some more exciting stuff.
Yep. Thank you.
Thanks.